Hello, it's Scott Manley here, and I am with Kelsi Singer. Hello.
I
So yes, today everything's getting really excited because we're almost at Pluto, right? And you
indeed.
are on the front line of this.
Yeah, so tomorrow is the big day of closest approach. So today we're calling Pluto Eve, and it is actually kind of like Christmas. There's a lot of it's like if you took all of your Christmas anticipation from most of your life and squished it into one day because we're really excited for all the observations the spacecraft is going to make, and then really excited to get that data actually down. So it really is kind of like Pluto Eve around here.
Wow. And so this is just basically it's going to fly past Pluto and there's going to be no transmissions back during that phase because it's just
Correct.
sciencing the heck out of everything there.
Right. So we can't point both at Earth to send the data back and at Pluto to take the data. So that's why we won't hear from it until the evening of the 14th.
Right. And then the first thing it's going to send back is like a I'm alive.
Right. We call that the phone home, appropriately named, and it just says, I'm still doing fine. Everything's operating nominally. We won't get a picture back at that time. It'll just be information sent from the spacecraft.
Right, and then after that, the big priority is the biggest and bestest picture of Pluto, as I understand.
Yeah, so that's so we as we're flying in, there's the camera field of view, and for the camera that takes visible images, it's a square. And as you're getting closer and closer to Pluto, Pluto gets bigger and bigger, as you can imagine. It's like getting bigger in the windshield. And so at one point, we get close enough where Pluto just fills the field of view. And then after that, the field of view will be smaller than Pluto, and you'll need multiple pictures to get all of Pluto in the mosaic.
Okay.
So yeah, so that big picture where Pluto just feels the field of view of the camera is what we'll be getting. Actually, we'll reveal it on the morning of the 14th. And so we're getting that right before it goes into the quiet mode.
Right. Okay. So that's great then. That's gonna
Yeah,
be
it's
super exciting.
it's going to be very cool.
Because up until New Horizons, you would get images from Hubble, and they would be like 10 pixels across at
Correct.
best with
Yep, yep,
enhancement, right?
yep.
And now we've gone way past that. We've just had an image from the 11th I saw, and it shows craters.
So there are some features that look suspiciously circular, and especially on Pluto, there's been so much geology, other kinds of geology going on that may have eroded and erased a lot of the craters. So there's some suspiciously circular features, but they're not in-your-face craters yet. So we need higher resolution to make out if they really are craters or not.
I'm sure that will be coming soon.
Yep, yep. Hopefully with that full frame.
But yeah, I mean, we don't really know exactly about the impact or environment in the outer solar system. I mean, we've seen impact craters on the moons of Neptune, which is in the
Yep,
same vicinity. But,
yep.
Pluto has a lot lower gravity. It's not inside the gravity well of a large body, so the impact rates will be lower and slower.
Exactly. Yeah, yeah. So the typical impact speeds are about 2 kilometers a second. I don't remember exactly what they are for the moons of Neptune, but for example, for the moons of Jupiter, because Jupiter is such a big body and has all that gravitational influence, the speeds on the moons of Jupiter for impactors is more like in the 20 to 25
Yeah.
and 26 kilometers per second. So it's a lot higher than the 2 kilometers per second at Pluto and Charon.
Yeah, yeah. And so, I mean, it's going to be a whole different environment as well. That's the cool thing.
It's a new regime for all sorts of fun scientific reasons.
Right. And Pluto, where do you stand on the planet versus dwarf planet question?
Oh yeah, always the question, of course. So, for most of us who study it, it's still that cool object, whatever we call it, right?
Yes. Yes.
So it hasn't changed since we've changed what we call it because planet is just a Greek word for wanderers because of course the planets move differently in the sky than the stars. So it didn't have like a scientific definition, and that's of course why they were trying to give it one. I mean, my field is called planetary science, so you'd expect there'd be a definition, a scientific definition for the word planet. But for most of us, a dwarf planet is still a planet. Just put it out there. So we still think it's going to be an amazing world. We've already started to see it has all this really interesting and unique geology. And so for us, that's what we care about.
So Pluto was, downgraded, which doesn't really mean anything. But your
Right.
series was the first planet to do this, right? It was originally a
Right.
planet, and then it
Yep.
became a minor planet, and then it got
Yep.
promoted back to a dwarf planet. And of course, we've
Right.
got Dawn and New Horizons both, spreading the excitement of planetary science at the same time. So I think,
It's good
I'm all
timing.
for it. Yes.
Yep.
Now, you're a geologist, right? So you specifically are looking at surface features. What instruments are you actually going to be using, and what do you expect to see, and what information will they teach you, I guess?
Yeah. So I do geology and geophysics. So I'm combining looking at models of interior processes and looking at the surface features and trying to say, how did that surface feature get there? So what I'll be doing is partly what we call photogeology. And so we are taking pictures from that camera I mentioned, which is a black and white camera. And we're looking at, saying how long is this feature? How wide is this feature? How many of these features are there? And at some point, we'll actually have topographic data as well from combining images, and we'll maybe be able to say how high is this feature or how deep is this feature. So we use all those what we call morphometric measurements, and then we say what kind of models would actually make a feature of this height or of this length. What kind of stresses do you have to have going on in the surface? What kind of geologic processes would make those kinds of stresses and things like that. And so I'll be using both the camera data, and also we have a color imager. So it has 4 different bands. So it doesn't look just in the visible wavelengths, it looks in the other wavelengths, some other wavelengths as well. And so from that we can get what is called color, and there are some attempts to make it look true to the eye. But in addition to that, we can get compositional information, because different surface materials are brighter or less bright in those wavelengths. So we'll use that composition to also tell us about the formation of the features. So let's say a certain feature has a composition associated with it that's different than the surroundings. That could help us say that somehow either from internally or externally, this different material got to this location.
Okay, I mean, that's cool. And when combining images, what you're specifically saying in this case is you're flying past the planet. You take
Yep.
a snapshot, and then as you move on, you take another snapshot.
Exactly. So you're looking at it from slightly different angles. And just like our eyes are looking at things from slightly different angles, and we see 3 things in 3D that way, we can represent that using 2 different images looking from slightly different directions.
So you're going to be imaging many parts of the surface multiple
Yes.
times and combining that data to get topographic elevation
Yep,
data.
as much as we can. So, for example, there's some that are from farther away and cover a bigger area, but as we zoom in, it covers a smaller area, but it's the same area, and so we can use those as well to look at topography of the features.
So you're talking about LORRI, which is long range reconnaissance imager.
Yep.
That I was reading about that. That has a 1024 square CCD.
Correct.
My cell phone camera has higher resolution than that.
It's true, yeah. So, as I'm sure some of your viewers know, it takes a while to get a spacecraft actually out to Pluto.
It takes a while to build it.
Exactly. So this spacecraft was selected in 2001, and so they did all the things they need to do to build it and get it ready and test it for launch in 2006. And so that was very quick. And it launched in January of 2006, and it's taken 9.5 years to get to Pluto. But that was also actually very quick. So the way they did that,
fastest spacecraft ever.
Exactly, fastest spacecraft launch from Earth. Technically, Voyager is faster than us. So Voyager got more gravity assists going by the giant planets. We only went past Jupiter, where we did get a very big gravity assist. But I actually have a spiffy graphic I can send you showing the gravity assist for New Horizons versus Voyager, and they're just a little bit faster than us now. But we were the fastest spacecraft launched from Earth, and that's because they put a very small spacecraft, relatively low mass, on a very big rocket, and so that's how we got such high speeds being launched off of Earth.
Right, and this is a really, really tiny spacecraft. It's something like 450 kilos or thereabouts.
Yeah, I can't remember exactly, but it's something like that, and also it's about the size of like a grand piano.
Yeah,
so it's
with the giant dish on the side.
Right. Yep. It's not a huge spacecraft.
Right. But I mean, for comparison, Cassini, it had the Huygens lander, which was just over 300 kilograms. So this
There you go. Good
spacecraft
example.
is practically the same size as the sub-satellite or sub-probe
Yep.
on Cassini.
Yep.
And yeah,
So
it was on an Atlas V with the first time they had 5 solid rocket boosters. Then they had a Centaur burn when the Centaur escaped Earth's gravity, reached escape velocity. And then they had a Star 48 kicker, which kicked it up to the Jupiter encounter, right?
So all of that has really helped it get there in 9.5 years instead
Yeah.
of a much longer window of time.
Yeah, I understand that the kicker motor actually kicked it a little too fast, and they had to use the rocket motors on the probe to slow it down, so the kicker actually got to Jupiter first.
Oh, actually, I didn't hear that. So now I know.
I read about the rocket dynamics side.
That makes sense.
Yeah,
So, yeah.
and I've also was reading that they weren't 100% sure about the Pluto environment until recently. They were slightly concerned that it
That's
might
correct.
hit something.
Yeah, so actually after the launch, they were discovering more moons. And so they started to get worried, like, how many moons are there? If there's more moons than we originally thought, does that mean there's more dust in the system? And even, dust as small as like a grain of rice would obviously have a big impact on the spacecraft.
Literally
it's traveling,
a big impact.
at 14 kilometers per second. So, if you hit a grain of rice at 14 kilometers per second, that's going to do some damage. So, so they got really, we should take this seriously. It might be a dustier environment. There might be rings. And so they actually launched what we call the hazard search. And so they did a lot of investigations, trying to look very deeply with the Hubble telescope, as well as modeling how much dust could be in this system. And fortunately, most of those moons, especially because Pluto, shares a mutual orbit with its large moon Charon, have predicted to have cleared out most of that dust. And it happened to be true. So I think most of us thought we'd find at least maybe one small moon, and we actually have a prediction pool going on. But I mean, unfortunately, we haven't found any. But that's interesting in itself because it's telling us that this system is pretty, evolved, and that's the way these moons formed. And there's not a lot of tiny bodies left over from that formation.
Because in the Edgeworth-Kuiper belt, you actually get a lot of these objects are formed as binary systems, and there's some good evidence that that's from their formation.
Yep.
And
so we think, I was going to say, for example, for Pluto and Charon, though, it's thought to have been a giant impact that similar to the giant impact that formed the Earth's moon, that formed this very almost equal mass binary system. I mean, Charon's half the size of Pluto, but they're pretty close in size compared to most systems.
Right. Well, the difference in mass is close enough that there's no stable Lagrange points, right?
Yeah. So your viewers might know about the barycenter, and it's outside of Pluto, whereas obviously for the Earth moon system, it's well inside Earth. So. It's a pretty interesting system.
And so do you think...
I was just going to say, so we took that potential hazard very seriously, and up until a few days ago, there was still a lot of tension waiting to see if we'd find any hazards, and fortunately, we have not.
We haven't found anything. We haven't found any rings, because the rings were...
We have not found any rings yet, although our best observations to look for those. So if we saw anything, it would be pretty tenuous, but we'll be actually looking back. So after we fly right by Pluto, we're going to take a lot of observations looking back, and that'll be our best time to try and see any kind of small rings occulting the sun.
And that'll be the time when you say, oh, it's a good thing we didn't follow that particular route, right?
Exactly. Yeah.
Look what we just missed.
Yeah.
So you're saying Pluto Charon forming via a giant impact event. Does that explain, or do you think that might have some contribution to why it's so different from other objects out in that region of the solar system, even other dwarf planets of comparable size?
Yeah, so we haven't found anything quite like Pluto yet. So there's another large body called Eris. It's probably just slightly smaller than Pluto, and it's very comparable in size, but it doesn't have a moon half the size of it like Pluto does, as a smaller moon. So Pluto is a unique system in a lot of ways, also because it comes just inside Neptune sometimes, so it's closer than a lot of KBOs come to the sun, and it has this great mini solar system going on.
Yeah, I mean, but it's spectrally very different from Eris and
That's
Haumea.
true.
And all the others.
Yep. So it's actually more similar. Pluto itself is more similar to a moon of Neptune called Triton in terms of its size and surface composition. So it's got a lot of nitrogen ice on the surface of Pluto.
So do you expect that, or do you think there might be a chance of seeing cryovolcanism on Pluto like we saw in Triton?
Yeah, I definitely think there's a chance. I think Triton has the best evidence for cryovolcanism of anywhere in the solar system. It's got these really interesting smooth plains, and if you have a lot of craters, you don't get smooth plains unless something comes and smooths over it and fills it in. And it's also inside those smooth plains, there's these little kind of crenulated looking things in the center, which could be something like a volcanic caldera. And so I think Pluto has a lot of chance of being similar to Triton in that way. So we'll find out soon enough.
So is there any fun predictions you want to make for things that we might see for the first time, or anything?
Well,
predictions, come on.
Yeah, no, it's hard because I mean we expect
you have
to
your
be surprised.
academic, your academic
totally.
credit.
Yeah, but to be completely honest, we actually expect to be surprised. Every body that we've gone to, we've been surprised by what we see there. And I would be surprised
if you weren't surprised.
Yeah, I would be surprised if we don't see any craters on Pluto. But again, there's a lot of potential for active geology there. There's a lot of, and also Pluto has this tenuous atmosphere, so it's a little different than some of the other icy moons of Jupiter and Saturn because there's actually a lot of interaction in between the surface and atmosphere. So there's sublimation and redeposition of frost over these interesting seasonal cycles. So that could get rid of a lot of topography.
Yeah.
But what I hope we see is something of relatively recent activity, even if it's not going on today. Something like plumes would be awesome. Like we've seen on Triton, you can actually see the plumes sticking off the surface on Triton. It's really fascinating pictures.
Yeah.
I would love to see like sort of smooth terrains indicative of cryovolcanism. We're already seeing really interesting stuff. It's hard to tell what it is at this point, but there's these really interesting dark and bright patches, and they're becoming more and more resolved, just like the bright spots on Ceres became more and more resolved. And so that's our version is the dark patches.
The dark patches, so versus the white patches, which is cooler?
Right.
Well, we know which is cooler because Pluto's further away.
We have both on Pluto.
And have you given any comments on Charon as well, or the other minor moons?
Yeah. So Charon's turning out to be also very interesting, and it's different in color than Pluto. So Pluto has more of this kind of beige, not quite orange, kind of brownish, orangish color to it, and Charon is pretty much gray. And something that no one predicted was that we've found is that Charon has a dark polar cap. So most people are familiar with, polar caps on Earth or even Mars. They're bright compared to the rest of the surface. But on Charon, we see this dark polar cap, which is totally, unique and interesting. And we're also starting to see some brighter features that could be craters with bright rays. And so there's certainly, one of my expertises is in cratering and crater physics. And so we're certainly going to see some craters on Charon. So at least I won't have, I'll have some craters to look at and study at least.
Yeah. I'm a big fan of physics myself. Craters myself. Let's say.
Yeah, exactly.
Big proponent of asteroids. But so so a slightly more let's say social question, I guess. Obviously, you're a scientist. You're waiting for the data to come back, and that will indicate success of the New Horizon mission. But it will also be the time when you have to start working. So when do you celebrate? Do you celebrate when the data comes back, or?
That is a very, very good question, because I was asking that myself the same question earlier today, because it's true that we've been waiting for this moment, tomorrow, which is the moment of closest approach. But then we'll actually start to get really the better data back. And so, most of our jobs are just beginning. But I'm pretty sure we'll celebrate tomorrow. So there's no worries about finding some time to celebrate.
Popping the champagne or whatever, right?
Yeah, exactly.
Yeah, well, that's great. It's good to know. Yeah, this is It's an amazing, exciting time, and yeah, as I said, wish I could be there.
Hopefully, you can live vicariously through all the fun stuff.
Oh yes. But anyway, thank you, Dr. Singer. It's very, very happy to talk to you. It's been very educational. And so
Great. No, I had a good time. Thanks for inviting me.
have a good one. Fly safe.
Thank you. Bye.